Hi everyone, I'm Eric. I'm a rising sophomore at Stanford University, and today I'll be talking about matching markets. In particular, we'll be going over the deferred acceptance algorithm and some of its properties for solving matching markets. So as a quick warning, a lot of the things I might talk about might seem a bit abstract and new. Don't worry, we'll go through a worked example, so if there's anything that you have a bit of trouble understanding, just try your best to follow along when we go over the theory, and wait until we go through the examples, and then hopefully you'll understand better. Alright, so for a bit of an outline, we'll first introduce what matching markets are, and then we'll describe a mathematical model about how we can model matching markets in the real world. And then we'll go on to explain the deferred acceptance algorithm, we'll talk about what it does, and then we'll sort of talk about the nice properties that it has and why we want those properties. Finally, we'll conclude, and then I'll do a bit of question and answer at the end. Okay, so a bit more on who I am. I'm majoring in mathematics and economics as of now, and maybe some more. And some of my hobbies include biking, chess, twirling lightsabers. If you're interested in that, I would be more than happy to share more. But yes, I don't just do this math and economics. I also have a life outside of this. Okay. So, first of all, why should this presentation matter? I think the biggest part of this is that we'll introduce economics from a completely different perspective. So, in your head, when you think of economics, the whole thing you might think about is prices and selling goods and markets. But the whole point of today's lecture will be on markets without prices. And at first, it might seem impossible, right? The whole point of a market is you have different goods at different prices, people can buy things, and everything works out because of prices. So what does it even mean for there to be a market without prices, and how can markets even exist without prices? And we'll be hopefully answering those questions throughout this lecture. And second is, beyond the actual content that I'll be sharing, there's also going to be a lot of new thinking and a new way of thinking that will be introduced. So in particular, a lot of what we go through will have a lot of close logic, right? We'll use logic to deduce steps, several steps at a time, and then from that we'll get certain results. And even though it's not math in the sense that there's no real numbers involved, it is math in the sense that we're using logic to prove certain statements about our model. And if you decide to do anything related to STEM, so economics, math in particular, and even in computer science, this sort of reasoning will definitely play a role in your future. So even if you can't fully follow along, just any sort of exposure at this point in time will help you farther down the line. Okay, so let's start off with talking about what matching markets actually are. So as I mentioned before, in traditional markets, everything is dictated by prices, right? And the other thing is that goods don't care about what buyer they end up with, right? When you go to a grocery store and you buy an apple, the apple doesn't care that you buy the apple. The apple doesn't have any preferences over who buys it because the apple is static, it's not an actor, it's just a commodity that we don't really care about. Furthermore, there is no direct competition between different individuals in a market with prices, at least in most of the time, right? When you go to a grocery store and you buy an apple, you don't need to have a fight with the person next to you over who gets what apple, because you would expect there to be more than enough apples for everyone to be able to get an apple, as long as you're willing to pay the price. So in this sense, we don't really need to use too sophisticated tools when analyzing what someone does when they enter a grocery store, right? Someone goes into a grocery store, they look at the prices, they look at how well off they would be buying possible goods, and then they buy what goods that makes them the happiest given the amount of money that they have. And that's it. You only need to analyze one person at a time given fixed prices, and all the analysis goes through. However, matching markets are slightly different. So first is that prices might still be involved, but prices are not the only thing that dictates who gets what. Second, both sides of the market might care about who they match with, right? So if we were to match students with universities, for example, a student cares about what university they go to, but universities also care what students they accept. And third, individuals might compete for the same good. In matching markets, you oftentimes see that there's a very small amount of possible goods or a very small amount of different people on each side of the market, and in which case if someone else matches with what you want to match with, then the good that you want is gone. So there is direct competition between what you do and what everyone else does. And in this sense, we can't really rely on our single player analysis from before, since what outcome is selected is dependent on the actions of everyone involved, not a single person at a time. Okay, so for some examples, first is our motivating example that we'll work the most with throughout this lecture. It's graduating high school students and universities, right? High school students want to go to universities want to enroll high school students. There's preferences on both sides, and we have a matching market. So in general, these other examples happen when there's preferences on both sides and finite number of goods. So workers and employees looking to hire workers, doctors who are graduating medical school and the first hospital that they go to complete their residency. You might have some more homogeneous markets where both sides are more similar. And one example of that would be individuals seeking out partners on a dating app, where you have men and women, or in general, one partner and another partner, and they want to try to match with one another to have a better life for themselves. Another example might be customers who want customer support and people who are answering customer support calls. In this example, we really have a finite number of the resource. You've probably experienced, or maybe your parents have probably experienced waiting long hours, maybe not hours, but waiting a decent amount of time to speak to someone who's available about customer support. And in this case, how matching works is really important. Okay, and there's other examples. There are also examples where, once again, we might have one side not care about the other side. For example, kidney donations and people who want kidneys. But that's beyond the scope of this lecture, and we'll just focus on the examples where both sides have preferences. Okay, so now that we've provided a real-world examples, let's actually define our problem mathematically. So this is where it might start getting a bit confusing, but just try to follow along as best as you can. So suppose that there are n universities and n students, where n is just some arbitrary natural number. For our purposes, our worked example later on will use 3 universities and 3 students. So you can just interpret, for now you can just interpret maybe n is equal to 3. So there might be 3 universities, we can call them U sub 1, U sub 2, U sub 3. And once again, there's also 3 students, so S1, S2, S3. Okay. And each university has preferences over students. Each students have preferences over universities. And the way we represent preferences is like this. So each university has some sort of ordering over students, and each student has some ordering over universities. So this kind of fancy greater than sign, this just represents that student 1 is preferred to student 3, is preferred to student 2 for university 2. And for all intents and purposes, you can interpret this as just a greater than sign. But technically speaking, these are students, not numbers, so you have to use a slightly different notation. But the intuition is the same, right? Student 1 is greater than student 3, it's greater than student 2 for university 2. Okay, so now the question is, how do we match students in universities? And before getting to what we want, I'm going to talk a bit about what a bad outcome would look like. So a market might be unstable, right? And by unstable, I mean that if there are 2 people, one from each side of the market, who would do better by exiting the market and matching outside on their own, then no one would be willing to participate in the market, since if you go to the central market, matching market, the market gives you a result, and you realize that you could have done better on your own, there's no reason for you to participate in the market in the first place. You would go directly to the person you want to match with, and just match without ever bothering to participate in a centralized matching market. And one empirical example of where this happened was Boston's old high school assignment program. So what happened was that people wanted to pursue out-of-market options. Students and parents would go directly to schools saying that they want to enroll, and the result was that there was very long wait lists of students waiting to switch to a better school. And a secondary problem with this is that there were a lot of last-minute changes, since you can only accept a student from the waitlist once someone who's currently enrolled drops out, and that sort of processing takes time. And as a result, there was a lot of unmatched students, and there was students who were matched to suboptimal schools. So this is an example of a bad outcome because we don't want this sort of instability. So as a result, our goal is to find some sort of stable match between students and universities given their preferences. And to define stability, we first define what instability looks like. We call a student in a university who can do better just matching with each other compared to participating in the matching market a blocking pair. So formally, a university and a student is a blocking pair to a given matching if the following hold. So first, they cannot be matched with each other originally, right? Because if the matching market tells them to match to each other, then they're already matched together, and it's not an outside option if they decide to match with each other. Second, the university must prefer the student over the student that the matching market tells them to match with. And similarly, the student must also prefer to match with the university than with the university that they're assigned to. And then, on the contrary, a pairing is stable if there are no blocking pairs. So if there's no blocking pairs, then there's no two people who have any incentive to exit the market and pursue an outside option, which means that the result of the matching market is stable. There's no sort of deviations from the result. As such, a natural question is, will a stable pairing always exist? And if so, how do we find the stable pairing? And at a first glance, it might seem very difficult to answer this question, but luckily we have a positive answer, which is in the form of the deferred acceptance algorithm. Okay, so next, let's talk about what the deferred acceptance algorithm does. So first, each student applies to their highest ranked university, and if there is no university that they would like to go to, they don't apply to any university. After each university receives all the applications, they look at all the applications that they've received, and they tentatively accept the most preferred application and reject all other applications. For now, we assume that each university can only admit a single student, and this is purely for simplicity. Everything generalizes to the case where we allow universities to accept multiple students. Okay. So for example, if a university accepts applications from 3 students, they look at all 3 students, they consider which one they prefer the most, they accept one of the students, and then they reject 2 of the other students. Next, each student who has their application rejected from step 2 removes the university that they got rejected from and returns to step 1. And then once again, they repeat to step 1, they apply to their next highest ranked university, and so on and so forth. So basically what will happen is that a student will first apply to their first ranked university. If they get accepted, yay. If they don't get accepted, they apply to their second ranked university, and then their third ranked university, and so on and so forth. So there's 2 cases. Either a student ends up accepted at the end, or a student goes through every single university on their acceptable list. And if they get rejected from all the universities that they apply to, then no university is willing to take them, and that rejection becomes final. They don't get to match with any university. So once all students have gone through their lists by either staying at a acceptable university or by having applied to all the universities and having gotten rejected from all the universities, then nothing else will happen because no student is still in step 1. And at this point in time, our algorithm is finished. There will be a set of people who are matched and a set of people who are unmatched, and this is the final result of our matching algorithm. Okay, so next we'll go through a worked example. So suppose that there's students A, B, C, maybe call them like Alex, Bob, and Carl. And then we have universities S, N, and T, so maybe like Stanford, Michigan, and Tsinghua. And these are preferences. So once again, what this represents is that Alex likes Stanford more than MIT more than Tsinghua. Bob likes S more than T more than M. And Carl likes N more than T more than S. And similarly for universities, University S likes B more than C more than A, M likes A more than C more than B, and T likes A more than B more than C. So let's see what happens. So first, the way you solve these sorts of problems is, let's say we have student A, student B, student C. In round 1, what happens? So in round 1, A applies to their top-ranking university. They apply to S. B also applies to Stanford because Stanford is also Bill's top-ranking university. And finally, C applies to M. Okay. So right off the bat, we see that MIT only has one applicant, right? Only C applies to M. So this is tentatively accepted. MIT accepts Carl for now, but maybe Carl might get rejected later if another better student applies to MIT and takes Carl's place. But now what about Alex and Bob? So they both apply to Stanford, so Stanford has to compare the two. So Stanford looks at their preferences. They see that they like Bob the most, and they like A the least. So they reject Alex, and they tentatively accept Bob. So now on to round 2. So for now, Bob and Carl, they're both accepted already, so they don't do anything. They're still stuck with S and M. So A has to apply to a new school. A likes M second. So A got rejected from Stanford, so Stanford is off of A's acceptable list. So A moves on to their second-ranked university, which is MIT, and they apply to M. So now, even though Carl was tentatively accepted in step 1, MIT still has to consider between Alex and Carl in step 2. And when MIT does this comparison, they look at their list, they see that Alex is better than Carl for MIT, so Carl gets rejected, even though Carl got tentatively accepted in round 1. And Alex is now accepted to MIT. And for Bob, Stanford still only has Bob as their one applicant, so Bob stays accepted at Stanford. So now we move on to round 3. In round 3, Alex and Bob, they were still tentatively accepted, so that just follows through. But now Carl needs to apply. So Carl got rejected from MIT, so Carl's next best university is Tsinghua. So that's why Carl would apply to Tsinghua in step 3. And then Tsinghua has no other applicants, so even though Carl is the worst for University T, T has no choice but to accept Carl because they don't have anyone better to accept. And then Stanford has only Bill, MIT has only Alex, so everyone is good. So then step 4, nothing happens because everyone is accepted, so no one needs to do anything. And our algorithm is finished with our final result being this. So all in all, we have Alex and MIT as a match. We have Bob and Stanford as a match. And we have Carl and Tsinghua as a match. So this is our final matching after going through the deferred acceptance algorithm. If we had more universities or more students, the process to solving it would be the same. We list out all the students, and we proceed round by round and see what happens, until we get to a round where nothing else happens, at which point our algorithm is said to be finished. So now that we have an understanding of what the algorithm actually is doing, let's go through some of the nice results that we have about the algorithm. So before, our motivating question was whether or not our match would be stable, and I promise that the match is stable, and I'll show why that is actually the case. So to show why this is stable, this is the same thing as showing that there are no blocking pairs. Because by definition, a matching is stable if no one blocks it. And since a blocking pair requires both a student and a university, it suffices to show that no student will be in a blocking pair. And this is the ultimate thing that we will show to show this result. Okay, so consider a student, consider consider a student. If they were unmatched, then all universities have rejected. So if a student is unmatched, then they've applied to every single one of the universities, and they've gotten rejected from every single university, which means that no university would like the student more than who they're currently assigned with. Because for a university to reject a student, it must be the case that they gave up that student in favor of someone who is better. So every university is already better off than matching with a student, so no university would be willing to accept a student, and hence this student cannot be part of a blocking pair. So now consider if a student is matched with their nth best university. So now there's two cases as to what university that this student may try to form a blocking pair with. So for universities 1 to... So if they try to form a blocking pair with their first best to their n-1th best university, then they have already gotten rejected. They've already gotten rejected from each of these universities, so the university is still no longer willing to match with the student, which is why there can't be any blocking pair, because the university will not be willing. However, for universities n+1 to the end, then this is worse than university n, which means that the student wouldn't be willing to form a blocking pair with any of these universities. So we've considered all possible cases for students. A student can either be unmatched or matched with some university, but in either case, they won't be willing to form any sort of blocking pair, so no student can ever be part of a blocking pair, and hence there can't be a blocking pair at all, because both the student and the university must come together to form a blocking pair. Okay, so the second result is, how do we know that this algorithm finishes, right? Are we guaranteed to come up with a match? Because we already know that if we end up with a match, the match must be stable. So now the question becomes, do we know we'll always end up with a match? And once again, we have a positive result, that yes, we will always end up with a result. We will always end up with some sort of match. And in particular, it finishes in finite time. So this means that we won't ever get sort of endless cycles of universities accepting and students proposing and so on and so forth. So the key assumption here is that there's finite unis and finite students. And hopefully you'll accept this assumption, because if you look in the real world, there's clearly a finite number of students and a finite number of universities. Okay. So the first step in this proof is to note that the total length of all students' preference lists is finite. So what I mean by that is, if we go back to this example, each student has a list of preferences, and if you take a look at all the preferences for all students, this will be finite. So for example, the total length of this will be 3 plus 3 plus 3 is 9. And 9 is clearly a finite number. So if we add up the length of each preference list for all students, we'll end up with a finite number. And 2, in every iteration, the total length decreases by at least 1. And this is true because in every iteration, either a student is rejected, in which case we have that they remove a university and the total length of the preferences decreases by 1. Or if there are no rejections, then the algorithm is finished by definition. And this means that we automatically get our conclusion, right? By noting these two things, then you can only subtract 1 from a finite number a finite number of times. So what this means is that we know that in a finite number of iterations, our program will actually compute the desired matching, and that matching will be stable. Okay, so here are some additional properties that we won't prove because the proofs are a bit more involved than what we had previously, and also because of time constraints. So first, it's in the proposing side's best interest to truthfully list their preferences, but it is not in the receiving side's best interest to truthfully report their preferences. What I mean by proposing and receiving is, in our example, students apply to universities, so students would be the proposing side and universities would be the receiving side. But we can also imagine a world in which universities propose to students, right? They tell students to come here, and students compare universities and decide what universities to go to. So that would be university proposing, while the current system is student proposing. Then the proposing side gets their most preferred outcome out of all stable matches, while the receiving side gets their least preferred outcome out of the set of all stable matches. So the deferred acceptance is guaranteed to produce a stable match, but there could be other stable matches, and which side proposes determines how good of a stable match they get. And finally, the last theorem is called the rural hospital theorem. It states that in every stable matching out of the possible multiple stable matches, the set of individuals that get matched and the set of individuals that remain unmatched stays the same. Alright, and I want to conclude by talking about the overall process of economic research, in case this is what you're interested in. So the first step is to find some interesting economic issue. In our case, it was markets without money, and in particular, it was how do students and universities come up with stable matches. Next is we would come up with a mathematical model to approximate the real world. So this would be the slide where we said let there be n universities and students, and have students and universities have preferences over each other. Third, we would derive properties of the model and come up with the physical interpretation. So for instance, our property would be that there's always a stable match, and the physical interpretation is that the market wouldn't unravel. We would have people who are willing to participate in the central market. And if 3 doesn't quite work out, for instance, if the model is too complicated for you to actually derive any properties, or if the model is too simple to actually have any interesting properties at all, then you would go back to the second and third step, revise the model, come up with new properties, and keep on repeating until you have a desired outcome. Okay, so hopefully you learned something from it, and hopefully the example and the proofs helped. In general, the process of learning math and economics is kind of difficult, and even when you get to university, things will be even more abstract. But just stick with it, follow along the abstractions as best as you can, and if the class is good, then you'll have plenty of opportunities to work through examples, and it's through working things out on your own and going through the actual examples that you understand the theory better and better. Okay. So next, let's go on to question and answer. So first, why did I choose my major and pathway? My answer to this question is going to be kind of interesting. So when I was younger, I watched an anime called No Game, No Life, and it introduced to me the idea of game theory. So game theory is the study of how people interact given a strategic situation. What happens is we have some sort of interaction where people come, and we want to predict how people behave. And mechanism design, which is the area of economics that I'm interested in, kind of takes that around. So instead of being given a situation and being asked to predict how people would behave, we instead identify the outcomes we want, and then we come up with an institution that gets us these outcomes even when people are being selfish. So in this particular example, the outcome we want is for there to be a stable matching, and the process we design to get us to a stable matching is the deferred acceptance algorithm. Next, what are my most favorite and least favorite parts of my major/pathway? I think my favorite part is just conducting research. I especially like economics because it combines math, and math is fun for its own abstract beauty, but also economics is intuitive and there's clear real-world interpretations. So it's really combining proving a very beautiful theoretical theorem and then coming up with a way to apply it in the real world that I find is my favorite. I think my least favorite part is that research can sometimes get very difficult when things don't really work out. And it's just very difficult to do and very hard to get into. But it's definitely not for everyone, but if you're interested in thinking about hard things that have rewarding payoffs when you actually figure them out, then you should consider pursuing this field. Okay, so what does my workload look like? So to answer this question, I have to preface it by saying that my workload is definitely not the usual amount of work that is necessary. A lot of the times you can get by and do economics without doing a whole ton of math. But for me in particular, I like economics because of the math. So I really challenge myself with a lot of graduate math courses. So that's a large part of my workload. But you definitely can do economics without that much mathematics. So it really depends on you. But if you want more work and you want to delve deeper, there's always going to be more and more things to think about. If not, then just you can always pick less things. In general, economics isn't too difficult of a major to pursue, since I guess economic research isn't too difficult to pursue because at most universities, an economics degree is geared towards people who aren't pursuing research, which means that relatively speaking, you'll be better off compared to them. Okay, how did I make a college list and how many colleges did I apply to? I made a college list mainly by looking at specific professors that work at each college. So, for instance, Stanford is one of the best institutions for economic theory. We won the 2020 Nobel Prize in Economics for work in mechanism design in particular, and that's kind of why I chose Stanford as my top university. I applied to Stanford early action, so Stanford was actually the only university I applied to. But one piece of advice that I would like to say is if you don't have a college list already, don't worry too much. It was only really the summer before my senior year that I wanted to go to Stanford. Before that, I wanted to go to the University of Chicago. So it's more important to just follow what you want to do opposed to aiming for a specific university, because a lot of the opportunities at many universities will be similar, even if a particular professor or a particular program isn't there. The other universities probably have something similar or some tangential opportunities that can also get you what you want. Do I have any tips on essay writing for personal statements and supplemental essays? So I think for both personal statements and supplemental essays, don't be afraid to write multiple drafts and don't be afraid to start early. So first, writing multiple drafts. Many times what people have is they think, okay, I have 2 ideas for this essay. I don't know what I want to write about. And they spend all their time worrying about choosing a topic. And during that time, another thing you could do is you could write out an essay with the first topic in mind, and then you can write the essay with your second topic in mind, and then compare the end results. So I think there's 2 main benefits. First is that any extra writing you do won't ever hurt you. It'll just be extra practice, which means that writing 2 drafts would only get you better at essay writing. And second, it's much easier to compare 2 end results than to compare 2 ideas, because if you're just comparing ideas, you don't have much to work off. Instead of being stuck on just wondering what to write about, just write about anything you have in mind, write multiple drafts, and compare at the end. And similarly, start early. When I was writing my Stanford supplementals, I think I wrote 2 extra essays because from the year before I applied to the year I applied, Stanford took off 2 essays, and I started writing before the actual application for my year came out, which means that I wrote 2 extra essays. But once again, it's good practice, and even if those essays don't end up being used, you still have 2 extra ideas for other schools that you can turn those essays into. So it's always better to defer on the side of starting earlier and writing more. Okay, what do I perceive to be the most important part of the college application process? I think that a lot of students get really fed up with the idea of getting into a particular college, or because it has a very nice sounding name, or because it has a high ranking. I think the most important part is to find a college that's good for you, right? So when I decided to apply to Stanford, it's not because of any sort of rankings or because of any sort of endowment or anything like that. It's just that Stanford has Paul Milgrom. Stanford has the best professors for mechanism design, and that's the only reason why I really wanted to go to Stanford. And it's much better to pursue a passion than to pursue a particular college. And another reason why is because AOs, they read thousands of applications. They can tell if a student's being genuine when deciding whether or not to go to university. And the other thing is, if you apply to university with going to university as your end goal, then you'll be kind of lost after you get there, right? But if you apply with an intent to continue pursuing what you want to pursue, then you have a clear goal in mind even after going to university. What was my GPA and an SAT? Do you think they played a large role? My GPA unweighted was like a 3.9, like a 3.4 weighted, and my SAT was like a 1540. I don't think it played too much of a role. I mean, both my GPA and my SAT were good by any means, but they weren't like top 1%. So they're not like exceptional, they're just pretty good. My piece of advice for this is for both the SAT and for your GPA, there's diminishing returns, right? So if you have, it's much harder to get your SAT score from a 1550 to a 1570 than it is to get your SAT score from a 1400 to a 1500. So the better you are at the SAT already, the harder it is to improve. And furthermore, the better you are at it, the less an improvement matters, right? From 1540 to 1550, you're still the 99th percentile. There's practically no difference in these 10 points. So it's a much better use of your time to just spend it on extracurriculars or writing essays than it is to get like 10 or 20 more points on the SAT or to get your GPA up by 0.1 or 0.2 points. Next, what hobbies and extracurriculars did you focus on in high school? So I think my two biggest clubs in high school was speech and debate and physics Olympiad. For speech and debate, I think that my trajectory was kind of different because I practically stopped competing after my sophomore year because my partner was a grade above me and because of COVID. As a result, I took a more leadership role and I did more on the back end of things, which provided a different perspective on speech and debate compared to most other applicants. And I think that's just, even if I don't really have the opportunity to compete, you can always contribute to your club in different ways and in creative ways, and that will help you stand out in general. Okay, what study tips do I have? I think my biggest trick in high school was to sleep early and wake up early, which is something I should probably do more of now too. By that I mean like sleep at 11, wake up at 5, or instead of sleeping at 1 and waking up at 7. Because the later it is at night, the more tired you are, right? So from 11 to 1 o'clock, you might need to take like an hour break to get you through that hour. And you'll be working on a lot less effectively. However, if you slept at 11 and you woke up at 5, then from 5 to 7, you have 2 hours of being a lot more productive. And you can get more out of the 2 hours from 5 to 7 than from 11 to 1. If I ever did research, how did I come across that opportunity? So my path to research is kind of unique. I went to an economics summer camp at the University of Chicago. And when I talked to their professors, they were like, oh, you need to take like 3 more years of math before you can even consider doing economics research. And I think that is true to some extent. But I just went ahead and decided to investigate a question that I found interesting on my own. And I was actually able to connect with a professor. And the way I did this was, those colleges that send you emails to apply because you put your email on the SAT. I just replied back to those emails asking for research opportunities. And then like 10 replies in, I got a reply back from a college professor. And I ended up working with him for about half a year. And I got something published out of that. So just don't give up. Conduct independent research, or at least try to, because even if you have an unfinished product, going to a professor with an unfinished product and asking for feedback is a lot more convincing than just saying, oh, I want to do research in general. What are my plans after my undergraduate degree? Well, I plan to go to graduate school in economics, and eventually I plan to be a professor, just doing more research in theoretical economics. why is it important to learn languages? I think there's two reasons. First is that there are many, at least for me, like I've definitely read papers from non-American professors that have been very influential. So just being able to understand worldviews other than what you're accustomed to creates a lot of perspective and a lot of good discussion that can foster innovative research. And just in general, being able to communicate with people from around the world is key to collaboration on a global scale. And what do I think about LingoX's mission? I definitely think that it's a very important mission. I definitely think that I should have learned Chinese a bit more when I was younger. I can speak it, but I can't really write it, and I'm not too proficient in it. And one of the other things that I did with my economics is that there's a program where I participated in the past where we would interview farmers in rural China and decide if it's feasible to give them loans. And when I was interviewing them, I definitely felt that my lack of proficiency in Chinese kind of played a detrimental role. So being better at Chinese can help a lot with communicating with people from around the world and once again getting firsthand access to other perspectives. So hopefully this helped, and thanks for listening.